Okay, so there is this concept in AWS that's becoming more and more common, and something that the exam will test you upon, which is called the high performance computing, or HPC for short. So the cloud is the perfect place to perform high performance computing. So why? Because you can create a very high number of resources in no time, and you can spread up the time to results by adding more resources, and you only pay for what you have used. And once you are done, you can destroy the entire infrastructure and not be built a single time after that. But till the time you are running, you will be built. So the idea here is that when we have an extremely high number of instances performing computations for us, and then be done with it and just pay for what we used. So this is perfect. This is a great use case for the cloud, and something that AWS is encouraging you to do more and more. So why would you use HPC? Okay, well, to perform genomics, computational chemistry, financial risk modeling, weather prediction, machine learning, deep learning, autonomous driving, and so on, so on. And I have also seen the infrastructure of the autonomous driving data engineering pipeline. I have done multiple deep learning stuff, machine learning stuff. I have done the not the genomics. I have done the forecasting related thing, the AWS forecast also. So the question is, what services in AWS will help us to perform high performance computing? So let's have a look. So the first category is, how do we manage the data? How do we transfer the data into AWS? The first one is going to be the direct connect to move data gigabyte per second data into the cloud over a private secure network. So we have seen this in the detail. Then we have snowballs and a snowmobile to move petabytes of data to the cloud through a physical route, and then and they are usually great for the big transfers or the one-off transfers. And then we have data sync. Well, we have to install the data sync agents, and they will help to move large amounts of data between on-premise and NFS or SNB systems into S3, Elastic File System EFS, or FS6 for Windows. Okay, so this does make sense for the AWS Direct Connect. It comes up with like the 1 GB per second to 10 GB per second of speed. Now we talked about the data and its transfer and its migration or movement. Okay, now what about the computing and networking? So very important. This is also the first one is obviously our EC2 instances. We have CPU optimized or GPU optimized instances based on the type of the computation we are trying to do. We can also leverage spot instances or spot fleets for huge cost saving and auto scaling to automatically scale our fleet based on the computation we are doing. Finally, if our EC2 instances need to talk to one another and perform some computation in a distributed fashion, then using an EC2 placement group of type cluster is great to get the best network performance. In which case we have a low latency 10 Gbps network in this example. And for the cluster placement group, everything is going to be on the same rack, everything is going to be in the same AZ, same availability zone. Okay, next we how can we go even further to improve the performance of the EC2 instances, our EC2 instances? So the first one is EC2 Enhanced Networking, also called the SRIOV. Okay, and this gives you higher bandwidth, a higher PPS, packet per second, which is the packet per second, and lower latency. So, and how do we get this EC2 enhanced networking? The option one is, which is the most recent and popular, is called the Elastic Network Adapter, ENA, and this delivers you the network speed up to 100 Gbps, and this is something you have to know going into the exam. 100 Gbps Elastic Network Adapter. Okay, so ENA is for the EC2 enhancement networking and gives you higher bandwidth, higher packets per second, and lower latency. We could not say lowest latency, but it's lower latency. It's pretty great. Okay, Uh, Option number 2 is to use these very complicated things from Intel called 82599 VF, and that gives you up to 10 Gbps, and that was to be the old Elastic Network Adapter ENA. So it's legacy, but I am still including it here just in case this comes up in the exam and you see it, you know what it is. So both these things, the ENA and the Intel, allow you to get easy to enhance networking on your instance, but you can push this a step further and using the Elastic Fabric Adapter EFA, and this is improved Elastic Network Adapter. Improved Elastic Network Adapter. Okay, so how is that? So ENA is improved, EFA is the improved Elastic Network dedicated for HPC for high performance computing, and it only works for the Linux instances. Okay, and it's great when you have inter-node communication or tightly coupled workloads. So think about like distributed computation. So why? Because it's going to leverage something called MPI, Message Passing Interface. MPI standard, and this standard will bypass the underlying Linux OS to prove even lower latency and more reliable transport. So think of it like if you have a Linux instance and you are performing tightly coupled workloads, then using an Elastic Fabric adapter will bypass OS and provide you even higher network performance. So it is quite common in the exam that you will be asked to differentiate between the Elastic Network Adapter ENA and Elastic Fabric Adapter. Elastic Fabric Adapter or Elastic Network Interface or something else. So so this is a good, we are saying this right now, and you need to know, you need to make sure to understand these concepts very, very clearly. Okay, so we have transferred the data, we are computing over the data, and we have configured our network. These three things done, but how do we store the data? So multiple choices are here. We can use the instance attached storage, so we could be that could be like EBS, and this can scale up to 256,000 IOPS. If you use IO2 block express, then 256,000 IOPS. It could be an instance store, and we have seen this can scale to millions of IOPS, as because it is directly instance store. It's in the device, okay, and it's linked to the EC2 instance. So it's on a hardware. It's going to be lower latency, and we can directly connect it with bus. So, but we can lose it if we lose our instance. So this is like the temporary storage, it's going to be only used for. Then we can use network storage such as Amazon S3 to store a large blob of data. It's not a file system, it's to store large objects. Or Elastic File System EFS, where the IOPS is going to be scaled based on the total size of your file system. Or we can use a provisioned IOPS mode on the Elastic File System EFS to get the higher IOPS. But we have seen there's a file system that's dedicated to HPC, high performance computing, which is called the FSX for Lusser. FSX for Lusser, and Lusser was for the Linux and cluster. LENUX for the Linux and cluster. Lusser was for Linux and cluster. And it's going to be HPC optimized distributed file system. Gives you millions of IOPS, and in the back end it's backed by S3. It's backed by S3. So lots of option again for the storage. Finally, how about automation and orchestration? So the first thing we use is batch, which is Mumble's a support service to perform multi-node parallel jobs, and enables you to run jobs that span multiple EC2 instances. So they are batch jobs, and it's very easy to schedule the jobs and launch the EC2 instances accordingly. They will be managed by the batch service. So the AWS batch is a very popular choice for the high performance computing. So we can use something called the AWS Parallel Cluster, which is an open source cluster management tool to deploy HPC on AWS. HPC on AWS. It's configurable with text files. It's configurable with text file, and it automates for creating of VPC, and it's automates creating of VPCs, subnets, cluster types, and instance types. And this is something, an option again you can see in the exams. So to summarize, HPC, high performance computing, is something that comes up more and more in the exam, and it's not a service, it's a combination of service and different option, and you need to make sure you understand all of those to maximize the potential of computation within the AWS. And I hope that for this lecture was helpful. All right, that's it. I will see you in the next lecture.